TechTalk.com. We are still continuing with some explanation of the effect of refraction. Now let's look at a stick partially immersed in water. A stick partially immersed in water. That if I have my liquid here like that, maybe if that is the container, we get a better marker pen here. And if I have this and I have a stick I've decided to immerse in water in a slanting format like this, okay, light rays will come from here and then when it is moving out, it will bend away from normal to someone's eye here, and as a result this other one here will be something like this. Okay? And now what happened is this one here will result into this one here to be seen something like that. And now you realize that this stick, now this person will see it as it is bent. Okay? So this is our liquid. That what happened is, if you put a stick in a slanting format or a ruler, anything in liquid, what happened is, if you look at it, you look at it as if it is bent. But what happened is that when you put this stick in a slanting, specifically slanting, if you put it vertically, you will not see it. If you see it, you put it slanting, what happened is light rays from the tips in water here will move into your eyes. But in the process of moving into your eyes, it is moving in two mediums, in media. That is the water and the air. So as it is moving from water, which is more dense than air, what happened is, we said that when light rays move from more dense to less dense, it is refracted away. Is that it? It is refracted away from the normal. Is that okay? So that means that if it comes here, it will move this other side to your eye here. But your eye here will not see the impression of the fact that it is bent. Instead, you will see it as a straight line coming from here. And then what happened is, this side here, in your eyes, it will look like it is now here. So at the end, you will see this portion as this. And now this other side outside will remain in its position. So for you, what you will actually see will be now, will be this and this. And when you look at this and this, it looks bent. So that is the reason why a stick appears bent. So what can we write about that? You can say, when a stick is placed in water in a slanting in slanting way, it appears a bent. Okay? Now, why does it appear bent? Then I would say part I can say light rays from the bottom part of the stick moves from more dense medium, okay, to less dense medium. Therefore, refracted away from the normal line. Okay? That the light ray that is from this tip here, as it's traveling from this more dense medium to the less dense medium, it is refracted away from the normal line refracted away from the normal line in the observer's eye. And then I can say the observer in air sees the rays in straight line as coming from the raised part of the stick. If this object, this eye, part of the stick at eye, whereas the outside part of the stick remains in its position. Okay? As a result, the stick appears bent. Okay? So we have said if you place it, light rays will travel from here, coming to your eye. But as it is coming in your eye, it is going to move from liquid to air. And therefore it will be, when it comes like this, it will bend away. Isn't it? From the normal. So if it is bending away in your eyes, you will not see the fact that this light has bent. Isn't it? Instead for you will see as if it is moving in a straight line. That means that if you will see it coming from this point here. And that is why you will see this part of the stick as if it is here. And now when it is here, it will look like this is like this. And now because this part remain in its position, this one remain here, and now this part here will look like it is now like this. So at the end you see the stick as a bent. But what is bringing all that is the effect of refraction, making a stick placed in liquid or water to appear bent. Please, we have said that the observation can easily be noticed when the stick is placed standing. So let's now meet in the next episode of our video.